Okay, let's consider this question 27.2. So we're counting solutions to the equation w plus x plus y plus z equals 22, where w, x, y, z are all natural numbers. Um, yeah, okay, so let's look at question A. Question A is asking how, okay, actually, I don't have that much space on this page. Let's put A here. Question A is asking, how can we interpret this as a balls and bins problem? Okay, so let's look at this question. So basically asking how can we interpret the balls and bins question, and that's asking like how can we interpret this as the type of question where we have some amount of balls and we want to distribute it. This makes sense because we have 22 like balls or just numbers, 22 things we have to distribute into these four bins such that all 22 are given to them, so they sum up to 22. So since all the numbers are identical, we can look at this just as 22 identical balls into, and we have four numbers that we need to give all the balls to. So we have four um, labeled. I spelled labeled wrong. Oh, labeled, so they are distinguishable into four distinguishable bins. Okay, so let's look at B. Now it's asking us to calculate the number of solutions to this equation. So we can just look at this as stars and bars question, where we have. Okay, so I'll first give the intuition, then we can just use the formula from class. So the intuition is like we have 22 stars, right? Let's just say this is 22. And then we have four bins, so we'll have 3 stars to divide these 22 stars into four sections. So we like let's just place them arbitrarily. Let's place them here, here, here. So then this will be W, X, Y, Z. Then we'll have like in this example we have like 3 here and then 4 there, or whatever. Yeah, so we can see that each unique like placement of these 3 star bars will correspond to a like unique solution to this equation. Since it'll all have like a different distribution. Um, so if we were just counting the number of ways to organize these 3 bars and 22 stars, we have 22 plus 3 factorial um, over 22 factorial because all the stars are identical, and 3 factorial because all the bars are identical. So we have parentheses. So this is equal to 25 choose 3. Okay, now let's just check this intuition with our equation from class. Our equation from class tells us that we have 22 balls plus 4 bins minus 1, and then we have 4 minus 1 bins minus 1. Okay, and is this equal? Yes, we can see that this is equal to 25 choose 3, which is exactly equal to the answer we got from intuition. I like the intuition solution better than just using the formula because I can never memorize the formulas. But the intuition is like it's easy for me to do for any kind of question. Great. And I guess we can just evaluate 25 choose 3 really quick. This is equal to 25, 24, 23. Oops. 23 times 2 is 6, 4. Okay, this is equal to 2,300 solutions. Great. Let's do part C now. So what is part C saying? Part C is asking almost the same question, number of solutions, but we have some condition now. We have W, X, Y, Z all greater than 0. So this is kind of a hard question. Like, how can we tackle this? Because somehow we have to get rid of all the arrangements where the bars like right next to each other, or there's a bar in the beginning, which makes like or end, which makes like an empty box. But if we look at it from like a different angle, it's not that hard. Let's so if we just like give 1 to each of these bins beforehand, then obviously we'll never have an empty bin, right? We'll never have a bin equal to 0 because you can't take away balls, you can only add them. So let's just try giving 1 to each. So we give 1 to each. Let's just set these variables. W prime equals W minus 1. Um, X prime equals X minus 1. Y prime equals Y minus 1. Z prime equals Z minus 1. Okay, now let's write out this equation. We have W plus X plus Y plus Z equals 22. So we subtract 1, we subtract 4 from the side, so we have w minus 1 plus x minus 1 plus y minus 1 plus z minus 1 equals 18, and then we have w prime plus x prime plus y prime plus z prime equals 18. Now this is exactly the same question as the first part. So we just have 18, which is number of balls, plus 3 minus plus 4, sorry. Plus 4 bins minus 1 over 4 minus 1 is equal to 21 choose 3, right? Equals 21 times 20 times 19 over 3 times 2. This is 7, this is 10. 10 times 19 is 100 and 133, I think. Yeah, 133. Then this is equal to 1330. So you might be asking, like, how do we come up with this thing? This like substitution of w prime equals w minus 1. Because if this intuition comes from, like, if w is greater than, we need to come up with some equation of this form, right, to use the stars and bars method. If we don't have one of this form, we can't actually use the method. So since w, x, y, z are all greater than 1, we just do this to set them all, like, to just natural numbers. So, like, obviously if w is 1, then doing this will just make it so w prime is strictly 0 or greater, which we need for the stars and bars. We don't necessarily have to. We can just think about it like intuitively. Like if we have 22 balls and then we give 1 to each of the variables or each of the bins, then we'll only have 18 remaining. So we can just go straight to this step. Now question D is question D is almost exactly the same, except this time we have greater than 1. So what does this mean? That means that they all have to be 2 or greater. So we can just do the exact same substitution. Okay. Yeah. Oh my God, that didn't work. Okay. We can do the exact same substitution, but this time instead with 2's, because we know that each of the variables has to be 2 or greater. Now, if we do the same steps, or we just use the intuition that, okay, so we have to give 2 to each bin, so we'll have 8 missing. Then we'll have w prime plus x prime, that's a 2, plus y prime plus z prime equals 14, because we're subtracting 8 this time. Okay, now we should just do the same math. 14 balls plus 4 bins minus 1, 4 minus 1 equals 17 choose 3 equals 17 times 16 times 15 over 3 times 2. This one seems a bit harder, should be fun. 5, 8, 40 times 17. What's 40 times 17 is 680. Okay, that's our answer. And great. Okay, let's do our last part. Wait, this is not our last part. Let's do E. So calculate the number of solutions with the conditions. Okay, so now we have like 4 different conditions. Yeah, we can just do it the same way, like almost exactly the same way. Either using intuition or using the substitution idea. Let's just use the substitution idea because it's more like it's more formal. So now w has to be greater than 0. So we actually have no condition on w. Wait, yes we do. We have the same condition on w as in part C, where it's greater than 0. So we have minus 1. Now for x we have greater than 2, so we know that x will be 3 or greater, so we subtract 3. Y is greater than 1, so it'll be 2 or greater, so subtract 2. Z will be 4 or greater, so subtract 4. Okay, now we just have, when we substitute it in, we have w prime plus x prime, that's a 2 again, plus y prime plus z prime. Z prime equals 22 balls. Okay, so we're subtracting 1 plus 2 plus 3 plus 4. Okay, and this is equal to 10, so this will be equal to 12. So now we just, similar question. We have 12 balls, 4 bins minus 1, bins minus 1 equal to 15 choose 3. I'll just do this on my head. Should be 455. Great. Now let's do our last part. Maybe I'll just I'll just erase part B or something. Oh, I guess I need a bigger eraser. To make space for this question, I'll just erase these two parts. Okay, let's look at F. So this one's pretty hard. It's asking a condition on only one variable. So, but this time the condition is not greater than, it's less than. So it's not a very easy question, but we can do it. So we have number of solutions with a condition less than. So let's just consider the complement instead of doing the less than. Let's consider greater than because we know how to do that from the previous parts. So first of all, we know the total number of non-negative solutions, which is just like with no condition at all is, okay, unfortunately I erased it, but it was 25 choose 3. Sorry. 25 choose 3, which was equal to 2300. Okay, so that's our total number with no conditions at all. But now we can place like the complement condition on this, which is W is greater than 3. Right. And only W has to be greater than 3. So now we know how to do this question because we just did this before. We know if W is greater than 3, then W will be 4 or greater. So we can set W prime equals W minus 4, and then X prime equals X. We don't even need to do this, but that's how you would do it. So now we can set the equation W prime plus X plus Y plus Z equals 18 because we have to give 4 to W to start with. You would just get this from W plus X plus Y plus Z equals 22. And then when you subtract 4 from both sides, you can substitute with W prime. So we try to solve this with the same method as earlier. We have 18 balls plus 4 bins minus 1, 4 minus 1 equal to 21 choose 3. This is actually the exact same as part B, which unfortunately I just erased. I'm pretty sure this was equal to 21, 7, 19. Okay, it's equal to 1330. So now our total number of solutions is just the total number with no condition, which is 2300 as we found up here, minus the complement of our condition, which gives us 1330. So then under our condition, we're given 970 total solutions. Okay, sorry, that was really long. I hope I covered the problem correctly.